Hello friends, let me talk on outliers today. An outlier or a statistical outlier is a data point that stands out of the main body of data, and out of pattern data is called an outlier. The cartoon to start with, here is the general body of data that fits a line fits well into the data, but there is a data that stands out of the main body of data. So it's saying its theory is wrong. Sometimes our outlier happens because of theory too, and it is being said outlier. It's not advisable to remove outlier all the time. So I'll talk about it. Start with definition. An outlier is a data point that differs significantly from the observations. An outlier may be due to variability of measurement, an indication of novel data, or maybe the result of an experimental error. The latter are sometimes excluded from the dataset. An outlier can be an indication of an exciting possibility, but can also cause serious problems in statistical analysis. So in general, when we analyze a general data, we remove the outliers for better results, so that we can apply any type of estimate, not only the robust estimate, etc. There are many theories behind it. Some examples. So if you draw a scatter plot, x-axis, y-axis, you can visualize the outliers that is standing outside the main body. That scatter plot. When you draw a histogram, that's a good looking histogram, but there is some accumulation of data that indicates the existence of a mixture distribution. So this is a general distribution that fits the data, but there is another distribution that is causing the outliers. That could be a theory. In box plot, we have quartile, first quartile, third quartile, median, minimum, maximum, and outlier stands out from the general data. So that comes in box plot. So these are the techniques to visualize the outliers, or you can say to detect the outliers visually. We apply these techniques whether there is an outlier in data. So some methods of detecting outliers. One that comes to mind is Tukey fence. Tukey fence is proposed by John Tukey, an American mathematician and statistician, that uses quartiles and interquartile range, IQR, which is Q third quartile minus first quartile, third quartile minus Q3 minus Q1. So Tukey fence uses the quartiles and is robust. So what is the Tukey fence? Any data falling outside Q1 minus K times IQR interquartile range to Q3 plus K times IQR is called an outlier if K is equal to 1.5. If we use 1.5 here, that's a bound beyond which all the data is an outlier, and will be called a far off data when K is equal to 3. If some data falls out of the region when K is equal to 3, it is called a far off data, the extreme outliers. So that's Tukey fence that is generally used in data analysis because it's based on quartiles and is robust. We can think of Moholy-Nevis distance as an anomaly detection method. So for a data Y from the population with mean mu and variance covariance matrix sigma, the distance function is defined as square root of y minus mu transpose sigma inverse y minus mu. So if we use the identity matrix in place of sigma, it's the general Euclidean distance, but variance is not the same in all the axes. So we can use it is better to use sigma inverse that gives us an ellipsoid. Under proper scaling, Moholy-Nevis distance follows F distribution when the data is normal. That's also true. So when we have the distribution and the data, we can calculate the p-value, and if it is less than 0.05, we may call it an outlier. That's a method of detecting anomalies in data. how to handle outliers. There is a vast statistical literature called robust statistics. Books are available on it that that talks about robust estimators, robust statistical testing in that works in presence of outliers. In presence of outliers, to talk in short, say mean. If you take the sum of all the values and divide by the number of values, that the average, that's the mean, and it's highly influenced by outliers. If an outlier is present, the mean differs heavily, but not the median. Median based on the ranking, and however big the outlier is, the median remains same. So there is a vast literature, robust statistics, which talks about dealing with outliers. Finally, a bit of attention. It is not wise to remove outliers from analysis all the time. We expect the presence of outliers that may be that could be caused by various source of variations, including measurement error, existence of a mixture distribution, etc. In fraud analysis, when we find an outlier or an out of pattern data, we raise alarm. That's the way we use outliers in analytics, in fraud analytics. Investigating outliers may lead to a new insight in the data. New theory comes out because of explaining outliers. That happen. I'm not going to talk about that. So new theory comes out in by the way of investigating outliers. I'll stop here. Thank you.